So good afternoon to everyone. Welcome you to our eighth day session. I would say I would be. Am I audible? Okay. Thank you, Saujanya. I hope see in morning session would be helpful by increasing its new dimension by Dr. Sneha. So right. So actually see what's really important that these are small basics. What I've been basically reading about these image processing, these histogram, etc. They how all they lead to detection of such a life-threatening disease like cancer, etc. Right. So there you would have realized definitely you need to learn bit more things, but you are not very far if you are clear about the things, if you are clear about applying the basics, then you are always encouraged to learn more things. And that is actually the main role of the basics. So what I would suggest you wherever field, whatever field you are interested in. See, today in this session, I will introduce you another application that is basically in the facial recognition. See, the beauty of image processing is that it encompasses 360-degree from medical to non-medical with so many applications. Means if you really ask me the one area with the maximum application, that I think would be image processing only. So healthcare, yes, glaucoma is where basically yes, in eyes the person is to detect whether eye disease due to actually how much severe it is. So see, that's why we are telling you that you take any database and you apply the same technique, you are easily able to get the conference paper. And once you are able to do the bit minor thing, once you have understood it and bit some changes, general paper is also not difficult. That is the theme. But prime thing is that we need to focus at how these things basically are extending and what are the things which are basically making the road in the actual real life application. So with this note, we start with our this session. So first, before starting this work, this is basically about the facial recognition. This work was basically primarily carried out by research scholar Manisha, who, who under my supervision in her PhD. She just completed her PhD in the November 2025. So that is that work, right? That is in that same context. So we will see it here. So when it comes to basically face recognition, when you see basically the mobile, right? And you see the mobile, that on the mobile it is whether the even when you go to the basically iPhone, that is one of the key lock, right? The automatic lock opener. So this total pattern actually gets up, right? And what is the really important? It's open thing. See, what is important that it is open and it is unique one. Both the things are very important. Since it's open, so it can be taken very easily. It's very easily you can means it's nothing and it's secret like signature, etc. which is very, very closed one, only very few people know. But face recognition is a totally open one. And remember, and it's unique one also. That makes it, that increases its utility. What we are saying that biometric, it is again part of the general biometric concept. Biometric refers to the automatic recognition of individuals based on their physiological and behavioral characteristics. Remember, it contains all the things. It contains the signature also. It contains your habits, your how you are moving. So face recognition is one of the things. What is its important? It is openly, it is accessible, and it is unique. Physiological traits include iris, fingerprint, face, hand geometry. So other basically iris, actually that is in the base of the Aadhaar, fingerprint. See, for example, you would have seen it in the many documents when the along with the signature, people ask for it, the fingerprint, because the signature can be a fake or person can deny it that it's not my signature. But fingerprint, etc., can't you deny? Face is there, hand geometry is there, retina is there. That is basically DNA, deoxyribonucleic acid, and ear geometry. Behavior characteristics include voice, encompassing signature. See, there are two things, physiological and behavior characteristics. Physiological, see what is basically our, that is based upon our physics, and behavioral, see that's basically part of our behavior. That is voice, encompassing signature, it is keyboard stroke pattern. Among these biometric traits, face, fingerprint, and iris are the most widely utilized due to their robustness, reliability, and accessibility. That is the thing, that it is accessible. Other than face, biometric system or person identification, iris formally require physical contact or proximity. That is why face recognition is more popular than other biometric system. Even see on the airport, etc., you can see that it is very much frequently used because there is some physical distance also. The facial recognition system is a technology that identifies or verifies a person by analyzing facial features from a digital image or video frame and comparing them. So, by remember the key thing, now it is coming to the thing analyzing facial feature, which is coming from digital image. So, what is this word feature, right? And comparing them to a database of stored faces. So is it this part, this line? Now you are automatically, we are going towards the image process. Is it well, features have come? See, normally we are talking it. So what is basically the needs? We have seen the control environment that people stand in front of a camera, even in the attendance, etc. Also, we use it in front of a camera with good illumination conditions. Example, border pass, attendance, access control. That is the control environment. What is uncontrolled environment? This is basically people photo capture on random places like mall, airport, and traffic areas. This is basically of the attendance, basically attendance control, and this is the case of basically the airport on the right hand side. So what are basically the challenges here? Challenges is here, main challenge is occlusion. What is the challenge? To recognize the face. That how it becomes difficult to recognize the face. So for example, You can see here in this example, see here the former US President George Bush is basically is hiding the face of another lady. What is this thing? What do we call it? It is we call it occlusion by other objects. Self-occlusion. It may be a self-occlusion that, for example, it may be a non-frontal pose. It may be a facial accessory. About the facial accessory, what do you mean by the facial accessories? Facial accessories means, for example, this specs, etc. It becomes difficult, right? So it is hat, it is sunglasses, it is a scarf, it is mask. Thereafter, it is basically, for example, here specs are making the thing difficult, even the black aspect. Limited field of view. Limited field of view, see again the part is very less part is visible. There you have to basically find out partially out of camera's FOV. So here also this person, this old person becomes it becomes difficult to see its face. Extreme illumination. Extreme illumination, see, basically due to extreme illumination, it becomes gloomy and facial half of the part is basically a bit dark. So it again becomes very difficult to identify. Sensor saturation. In sensor saturation, we say basically either it is a underexposure or it is a overexposure that basically becomes a problem. So what do we say? See in this part, come to the say in applications. See when we come to the basically video surveillance, it is basically the CCTV control. It is a power grid surveillance, monitoring and searching for the drug offenders and known criminals. For example, the if you really see that the eyes of the police or the police best eye is basically the CCTV camera. And see thereafter you need to process the data in the different ways. It becomes really very useful. In the security, see when we see it, basically it is the office act. See, not only CCTV, so you even people put it their CCTV in at their homes and they are very easily able to see the every activity of their home from the distant place. Security. In security, basically what we say it is basically the office. In security, what we say it is office access, building access control, airports, flight boarding system, trading, terminal security, criminal justice system, post-event analysis and forensics. As we are saying, it is the main, basically main eye of the police branch. Image data sets investigation. So conducting searches across databases of licensed drivers, benefit recipient, missing children, immigration checkpoints and national ID record. So what we say that the image data set actually really helps to investigate, right? Basically these people at immigration checkpoint, missing children, etc. Human computer investigation. Human computer investigation basically imply that it is the proactive computing and interactive gaming. So another thing we call it basically the smart card application is to maintain a database of face image, face prints can be stored in a smart card, barcode, or magnetic strip. Video indexing. In video indexing, see what do you say? It is basically the labeling faces in videos, civilian applications, e-booking, and e-commerce. In video indexing, basically, when we able to locate out the person, okay, that this person is there, that person is there, that also can be done. Occluded face recognition approach here. In occluded face recognition approach, what you see basically it is a robust occlusion face recognition, occlusion aware face recognition, occlusion recovery based face recognition. So when we call it basically the occlusion detection and discard face recognition, right? So that is basically the part of the occlusion aware face recognition. And another is basically the partial face recognition. What do we say? For example, in the here we what we find out that in this. So how does it take place? All these things it takes place. These simple things. For example, first you use the image data. After image data, it is face detection, and then it is basically the pre-processing, and then occlusion detection. See what we are doing. Go by one. One by one, we go there. The face detection. First, you basically detect the face. Okay, so this is the face. Then you basically pre-process. If it is not face, then we'll discard that it is not face. The output input is not valid. In the pre-processing, see what do you do in pre-processing? If you see, we basically do the either the normalization or we basically put the uh, noise, etc. Occlusion detection. Occlusion detection. See how does it happen when you begin to observe the occluded detect images, then you are able to extract out the feature, and once you are able to extract out the feature, then features may be selected and they may be used for the face identification. So what is showing here? See, this is actually the part of this her thesis. So she has shown all the chapter. So what the work has been done by her that she provided the detailed information about the occluded face recognition problem, motivation, research, attribution. Chapter 2, we discuss the three main occlusion handling approaches as shown below. Occlusion robust feature extraction, occlusion aware face recognition, occlusion recovery face recognition. So what has been said that chapter 3 it basically provides. So what is chapter 3 here? That it does provide detailed information regarding our proposed work and implementation based on ORFR approach. Provide and detailed information about the occlusion detection and select the non-occlusion reason based on ORFR approach. So in 5C, what we are saying that we regain the facial feature using GSP based method based on this. So in this chapter two, we will go through see what are basically the literature thing. So when we come to the face recognition approach, they can't be divided into a four part. So four part basically one is the it is the occlusion robust feature extraction. So what we are saying here that in occlusion detection, you directly find out the occlusion in the partial phase. It may be the partial phase is not giving the best sight actually. Occlusion recovery. In occlusion recovery, you see finally you recover back and you lead to the face recognition. So what we are saying is the at feature extraction as we are drawing basically the first slide, it is the first topic, it conceptual. It is basically the patch-based engineered feature. Here it is handcraft feature. Here it is patch-based matching. But while the another case is it is learning-based features, it is statistical learning, uh, it is sparse representation classifier, and it is basically the deep learning. So in statistical learning, see if you recall, see that we have basically measured the first dimension parameter, that the mean, basically the variance, and that other group parameters, mode, etc., mode of a square, that is the So what has been shown here, see, for example, here see what you see that different techniques are there. Some of the techniques we are used, some of the techniques we are not used. So one of the techniques is basically the local binary pattern. So one is basically the local binary pattern. If you recall, see, we have already gone through the local binary pattern in the last lecture. What was local binary pattern? Are you able to recall? So what we are saying is in local binary pattern that you divide the space into multiple regions and extracts LVP feature distribution. So what is this one? If you see here, just for example, here it is basically the 5. Here we are seeing value and so what we are saying here is when we are taking this one, so when we are taking the LVP, so what will happen? See, what we do here, see, for example, 5 is there, so here see what value we have written. For example, 10 is there, so it will be 1. So whatever bigger value is there, so it will be 1. It is 21, so it will be 1. 8 is there, 1. If 3 is less than 8, so it will be 0. It will be 0. It is 4 here, it is 0. So, and this will be 1. So in this way, so how did we then decide? We are able to find out it is basically the local binary pattern. We start from the value here. For example, it is we start here 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, then 3, 4, 5, 6, right? Uh, it is 7. So we are able to basically calculate the value. What will be? It is 2 raised to the power 6. It is 32. It is 64, 64, 65. 65, it is 67, and it is basically 71 value, right? So that way, basically, we are able to calculate the LVP. Are you able to recall? See, we have just discussed it. Then we basically discuss the weighted chi-square distance basically for LVP. It basically measures the distance between two LVP-based phase descriptors, giving more importance to specific facial features. So remember, see, even see in facial features, see, it is, for example, the eyes are basically more distinctive to identify the person. Then we can give the more weightage. It doesn't mean that LVP, etc., that will give equal weightage to the every part. So thereafter, we are going for the scale invariant feature transform. Scale invariant, are you able to recall? See, there we took up the different sizes of the image, but feature size will not change. What did we call this term? We call that term basically descriptors that are invariant to scale, right? So you need to detect the key point, that are invariant to scale, translation, rotation, and illumination changes. So here, what do you find out? Here you find out the high dimensional feature vector. Histogram of oriented gradient. See, now you see whatever basics we have read it, they are coming now in the techniques for identification, extracts local object appearance and shape. See, what is the advantage of the HUG? That here you find out its shape basically, right? Using gradient orientation and apply the visual recognition. So here gradient based descriptor is there. What is its limitation? It is sensitive to occlusion. Remember, shape is fine, but for example, when some part is basically hidden, it will be very difficult to identify. Gabor filter. What is Gabor filter? Gabor filter basically it is said to be very the special one because naturally, if your eye contains some type of filter, that is basically the that uh, Gabor filter is based on that shape, that natural shape. Here you use a multi-scale and multi-orientation filters based on the frequency responsive. So here what is the problem? It is high computation cost and memory usage. Gabber phase feature. See, remember, because it becomes the very highly computationally intensive. So you also many times you can find out the phase only, phase information. So use phase information instead of magnitude for better discriminability in recognition task. So, but also even see, despite it, it is, remains computationally complex. Then basically you take the local Gabor binary patterns. You include both the things here and combines Gabor transform, LVP and local region histogram for robust feature extraction. So here high dimensionality here leads to increased computation and storage need. Another is basically pullback labeler divergence LGPP that measure the distance between local LGPP features of test and reference images to estimate occlusion probability. So here you find, so here the another problem is there that it is high dimension and complex and it requires efficient distance computation. See, many other more methods are there. For example, elastic bunch graph matching. So what you can do, see, whenever you have the time, you can go through these methods. Here, basically, a graph is used to represent a face where each node corresponds to Gabor and gets extracted from facial and distance is computed between corresponding nodes for matching. It is basically graph-based matching. It is sensitive to occlusions and requires accurate landmark detection. It is basically another concept that is based upon the like histogram of oriented gradient. It is a difference of Gaussian descriptor matching. So here extract and local descriptor from densely overlapped patches. Here each descriptor match with its spatial neighborhood theme, right? So selecting a minimal distance to improve robustness. So in matching complexity increases with the number of local descriptors. So random sampling patch-based method. So what do we do here when we use basically randomly sampled patches from the face image to train multiple SVM classifier? So you randomly take the sample, but remember again, see these more they are near to the key points, better will be the identification. But the major problem is on these technique where you are taking the sampling and the pattern that it is not able to take care of the occlusion. essential face patches are missing. So then coming to the problem of dynamic graph representation. Here you construct the feature graph where each node represents the face and edges capture a spatial relationship. What do we do here? We enable elastic and partial matching. So see what is basically done here. See, for example, when see this is bit rough type of sketch of faces here. So see what we can do here. So here you can see each node. See, for example, this is basically one node. That is basically another node. And that is basically the third node. So this is region 1, this is region 2, this is region 3. So what do we do here? We construct feature graphs and each node represents it, and these regions are also basically connected by the some edges. What do we call? We call this basically we used their interrelationship in the graph signal processing. What um, we what we have used here are. So coming to the part, see sub is so what is the key thing here? See here we are basically the patch feature matching, but thereafter see also this is the task after we are able to extract out the feature, then we need to reduce the dimension of the feature. Did you realize in the diagram, in the last diagram? See this one, this feature selection. So this is basically for the feature reduction. So what do we do here? Here we basically use a principal component analysis. Here you learn the most represented subspace from training face images. It requires proper alignment based on eye location. So this is very, very famous method. I hope in the beginning we used it to reduce the dimension of the feature vector. Why do we reduce it? Because it takes the time and also it reduces the computational complexity. Linear discriminant analysis. Linear discriminant analysis. Here you explore the discriminative subspace to differentiate individuals by incorporating class labels. It requires proper alignment based on eye location. Another is modular PCA. So modular again, it is a principal component access. Here it builds multiple eigenvalue spaces in facial regions to tolerate face variances. Here it is basically a region-based PCA. Another is basically robust subspace learning. So are you able to understand this? Subspace means basically from the part of the feature vector, we are able to train it, right? Robust subspace learning. So here we are basically develop robust subspace learning continuous optimization. So outlier detection PCA use basically PCA to detect occlusions and calculate coefficients use the remaining pixel. It is basically the outlier detection based PCA. In the robust PCA, see what do we do in robust? It basically combine the discriminative and reconstructive properties to achieve good classification while detecting occlusion. Independent component analysis. What do we do here? We extract basically locally salient information from facial part for better recognition under occlusion. Another one basically kernel correlation feature analysis. Here you use kernel based feature extraction on facial regions for partial face recognition. Confidence weighted subspace method. It weights basically image pixels based on confidence measures to reduce the effect of occluded pixels. So here you achieve this. So what is the ICA? Even it seems like the PC and LD, but it performs better under occlusion conditions. Right. So again about the kernel correlation feature analysis. Here it outperforms the PC, LDA, but again no explicit limitation. It is there. What this topology? They are basically linear subspace learning. Linear basically, for example, your facial features are represented there. So in that space, we do these different type of combination. Another is basically, yes, there is a lot of one that mixture of Gaussians for occlusion number base. So here, see, what do we use whenever we are using Gaussian, etc. Because see, when your occlusion is there, so then your this PCA, IC, etc. they become less effective. Then what is the option? Then option is basically use a probabilistic modeling with Gaussian mixture. To handle by selecting the largest missing areas and de-emphasizing occluded regions with low posterior probability. Again, it is based upon the probabilistic model. So in the limitation here, the occluded regions can always be identified to low posterior probability. Self-organizing maps with soft KNN classifier. So what do we do here? It is basically a topology preserving subspace learning. Here, uh, we represented basically face subspace using self-organizing maps to similarity between subblocks and a classifier. So it faces with soft KNN basically ensemble classifier. What is its limitation? It assumes basically prior knowledge of occluded reason, which may not be seen. Definitely, when you are basically in a lab setting, it is clear. But in the real world setting, it becomes very difficult that which part will be occluded. You don't know whether some person is coming in front of it or uh, any side face, etc. It becomes difficult. Local Gaussian kernel with SVM. So in here you basically extract out the local feature and you use a fixed size local kernel which is suboptimal as it doesn't adapt to different facial regions. So it is another is basically non-metric partial similarity measure. It basically captures partial similarities in face images while excluding unreliable local features. Here it is basically local similarity based feature extraction. Statistical learning of local shift features. Again, it is a scale invariant that we have just discussed. Scale invariant feature transfer. It is a basically the general framework for statistical learning of local features. What we are saying here that it extends statistical learning by integrating weighted local features and feature-based similarity for distance measurement. So what do we do here? That it is basically sparse representation classifier. Here you represents the test phase as a linear combination. So, of training sample plus a sparse error. So remember, so when you come to the basically sparse representation classifier, here you basically represent the test phase as a linear combination training sample plus a sparse error to model occlusion. Then you also use basically the structured occlusion coding SOC, right? Thereafter, then you use the structured occlusion coding. See, what is really important here that we are taking care of the occlusion because in the real life, when you see the faces, it is the not that the very controlled condition. Like for example, in the attendance system, etc., where the people are coming and they are showing the full faces, etc. But it is like the uncontrolled condition, like the CCTV, etc., where people are coming. You have to detect the phase that which person has crossed it, how many times it has gone through this region, etc. So this is the thing. So that's why the occlusion means basically the hidden part that becomes the major issue. In the same way, it is efficient locality constrained occlusion coding. It reduces the running time by estimating occlusions using identity unrelated samples. This is basically the slightly reduced accuracy compared to traditional SRC. Joint and collaborative representation with local adaptive convolutional features. So here, basically, you extract out local high-level features from regular regions and similar representation quotient for local areas. So remember, two terms basically very commonly used are there. One is basically the global and another is the local. Local is basically in the neighborhood only, and global is basically which lies in the apart from the neighborhood. These are the another techniques. So again, see, you need to go through the different tech. So what is important? We don't need to go through the every technique, but we can check any of the technique, and we can first we need to implement the technique, and then we can verify that how much, what is changing and how it is changing. So today, as we uh, also we in the last lecture we emphasized that it is deep CNN, because see, whenever this image etc. is there, many feature points are there where see actually this becomes very important. So here you use the deep CNN trade on massive data sets to obtain a highly discriminative face representation, data augmentation with occluded faces. What you are doing here you generate the occluded face samples during training to make feature extraction more local and robust. Synthesis of occluded faces. Remember, not only we need to see the actual face, but also we can synthesize the occluded face with hairstyle and glasses. Occlusion sensitivity based data augmentation. So here you basically identify high effect face regions and augments training data by applying occlusions more frequently to central face region. Deep dictionary representation. Here, see what do? You use the dictionary to linearly code the features extracted from CNN. It includes an auxiliary dictionary to model occlusion patterns. Deep feature representation with dictionary coding. So here now you see where you occlusion aware face recognition. It means you are aware about the occlusion. So what does it lead to? See, for example, here it may be occlusion detection based face recognition, or it is a partial face recognition. So what do you do in occlusion detection based? First you detect the occlusion, then you take the visible part of the selection, and then you find out the NMF feature basically, right? Non this median feature, and then you identify basically the deep learning. And here you use the partial face recognition. In partial face, basically, what do? You basically extract out the feature from the part, and then you compare the components and then multiple classifier system, and then you learn the classifier. In this way also it is done. So this is basically another occlusion detection face recognition approaches. So what we are saying in the occlusion recovery, it is basically another is the two things are different. One is basically occlusion aware and the occlusion recovery. In occlusion aware, see, even despite occlusion, the part of the image is sufficient to tell about the person. But here seen in painting basically you are basically trying to recover, you trying to recover it. So in painting it is basically non-blind here, then you use basically the deep learning for blind in painting. Another is basically reconstruction or the linear reconstruction or the sparse representation classifier or the deep learning. Either of the method you can use because the patch is big enough where the available features are not sufficient to recognize the face. Here you basically talk about the linear reconstruction. Linear reconstruction is what we are saying, that PCA reconstruction is the recursive error compensation. What we are saying that PCA against the principal component axis is limited to a specific occlusion type. It struggles with large occlusion. So another basically PCA variant for occlusion detection and construction. So what do we say here? See, here we say basically the linear combination reconstruction. Linear combination reconstruction, what does it require? Here it estimates occluded test images as a linear combination. So of training samples across all classes, and you assign different weight facial area to prioritize non-occluded regions. Requires occlusions in both training and testing set. So this is actually a long method because it's a PhD work. So long. So in deep learning, so you need, so whenever you need to any check out anything, etc., you need to go through. Then what is the technique used and what are their limitations? Whenever you are preparing for any PhD research, etc., you need to know what is the advantage and along with the advantage, what are the limitations that you must keep in mind. Because as soon as you keep in the your limitations, that will give you the key to the your research, right? Already the research has been done, so there you need to check out. This is a non-blind in painting, and what is the see again whenever you will so whenever you read any research paper etc. You need to check out in this way that it is struggle with large occlusions. It may produce artifacts in complex feature. This is such a topic based in painting where limited to small occlusions, but it is ineffective or complex occlusive pattern. So see, that's how you list out the different type of limitations when you are seeing the result. So then automatically when you are able to traverse through all these type of limitations, you get to know that what you need to do. Because the most difficult point in the research is that how to start with what to take. That comes from the good literature that has been shown here. So here again it has been series of these are all basically the part of the deep learning variational autoencoder. What is the limitation here? They generate the images tend to be blurry and low quality. Here basically the GAN, the generative adversarial network. What is the problem here? There it is basically unstable training model collapses. Then you use this is a convolutional GAN. In convolutional GAN, basically computation expensive and requires a large data set. Adversarial autoencoder. In autoencoder, see, you use basically the GAN framework for probabilistic autoencoder inference to ensure meaningful sample generation. It is susceptible to adversarial training and stability. It is blind in painting with a sparse coding and DNA. So this is the problem. Here you struggle with complex occlusion texture. So this is the three different techniques are there. Again, what we can realize here, the limitations here. Otherwise, all are bit technical. This is the research gap. So see how you are able to basically find out the then research gap. What are basically the research gaps that has been basically located? Actually, this is the work we started basically during the COVID time. Manisha basically registered in the year of 2019, and at that time, after 1 year coursework, then in the 2020 when Corona started, then that topic came to our mind. Let's see, the person is coming, okay, face mask is fine, but now it is not very easy to identify that person. So it is basically sometimes we say that the natural calamities becomes they provides the way, or we are indirectly thankful that thing that it provided it sparked in our mind that we should go toward the occluded phase. So during that time in 2020 only she started. That was a time period of around that's basically June only, right? Actually March, April only, doing the coursework. 1 year it's the coursework in MNIT. So in the research, yes, what it we recognize that it is basically deep learning face recognition models depend on large data sets and struggle with few short scenarios, it leading to overfitting and poor generalization under pose lighting and occlusion variations. Remember, learning image basics is one thing, but see, these are the realities. So, how you get the master of your subject when you begin to address these? The learning basic is one part, But applying the basic against the actual condition, that is, we say the complete task, that you make the task complete. So thereafter, it is basically GAN, it is generative adversarial network and deep reconstruction method. So what did we say? That deep learning large data sets and struggle with few short scenarios oversitting. So can we do something about it? See this data set, because it requires large data set, it is not available. Then what will you do? Not train your machine for a face recognition. Then GAN and deep reconstruction based methods often fail to preserve true identity. So basically, this is there. It producing visually realistic but ideally inconsistent faces, especially under heavy occlusion. Most occlusion aware methods train on clean faces and only test on occluded faces. Although some introduce synthetic occlusions, improve discriminative feature extraction, and these approaches remain computationally costly under severe occlusion. See, what is another problem, that whatever these they are there, we train on clean faces and only test on occluded faces. So you also need to test on the occluded faces. Existing model experience significant performance drops when key facial lesions. See, also, which part is you are occluded? For example, if it is the half of the part, it is eyes part, it really becomes very difficult to extract discriminative identity feature. So then we decided basically that research objective that to explore the different handicrafted and learning based methods on different occlusion conditions to improve accuracy in complex scenarios using a robust feature extraction approach. To extract discriminative facial features based on occlusion aware so this discriminative facial feature. So which feature can be selectively used when the most of the features are occluded? Improve face reconstruction method by restoring occluded facial parts and so what we are doing? Reconstruction method. See, right? Training, etc. See, are bit successful up to a certain point, but thereafter you need to reconstruct the thing. It is not possible. So, are you realizing? See, the facial recognition is one problem, but occluded face is basically when you need to recognize the thing with very limited value, with a very limited feature. So, that is this is the thing. So thereafter, that's why it is basically the thesis work of Manisha. So he written this presents a comprehensive review face recognition, highlighting advances in uh, extraction, comparing local versus global representation, identifies the key limitations, emphasize the need for more distinct feature. It is patch-based, non-overlapping dictionaries developed to effectively handle continuous occlusions such as masks or sunglasses. The proposed work improves accuracy when both training and testing images containing occlusion. This work proposes texture and geometry feature through new GFT, GWT, and then variant, right? So here see, as we also introduced as a topic of basically graph signal processing. Graph signal processing, see what do we do? As we mark out the different reasons and we try to find out the interrelationship between those different reasons. And that interrelationship is basically used to enhance the feature. And that this graph feature with limited samples, we are able to find out the faces. New reconstruction algorithms are introduced for accurate estimation, facialism by using key landmarks, more reliable head pose estimation. A synthetic occlusion database is created to support enabling development and testing. So remember, as it has been discussed, that faces are trained on the clean faces, and when they are tested, then definitely they are not likely to give the right error. So there also things can be. So here, see, you can see basically the things that in the data sets and in so Here you can see the case. Here, see, for example, the person is there. For example, with specs is there. One case, this is uh, here, and another it is mask. So here occluded preface. So it is real occlusions. When it is real occlusions, it is occluded faces, occluded prefaces. So definitely, see, you can't directly train your any algorithm on the direct occluded faces. First, you need to train on the occluded free faces, and then definitely with better feature, you are able to improve the accuracy of your algorithm. That's why it has been shown here that this is the real occlusion, there it is partial faces, here it is synthetic occlusion, synthetic actually you have created it. It is occluding rectangles are there, occluding unrelated images are there, there also you have been able to find out. So these data sets have been basically used here. So here it is summary. So this is basically AR data set here, 126 subject. So that you can see here. See how many, see, it will give you basically the size of the data, how much data is basically there. So in AR, basically 126 subjects are there, the 4,000 images. Yes, it consists of the real occlusion. Then you, case of the extend ELRV, it actually doesn't contain the real occlusion. It is basically in the related images is there. So here your subject is this much. And you use these number of images, ORL, etc. And ORL basically 40 subjects are there, 400 images are there. Again, it is basically a part of the rectangle. Ferret. So these are basically the different ones. If you hardly see any of the things which are based upon the real occlusions are limited data set, then what did you do? So can you think what should we do in that case when such problem is come? Can you suggest any problem? Can you suggest any solution for this problem? See, I tell you in that cases again you can use basically the synthetic occlusion. Synthetic occlusion you can introduce it if you really see in the see this one that we follow, occluding unrelated images that we introduced it. That were not basically the actual images, but we introduced. That is occluding rectangle. That also we introduced it. What is the see problem? The solution is basically the synthetic occlusion. Why synthetic occlusion? So that see basically you can train your algorithm with a lot of database. Otherwise, the real occlusion limited images are there and it becomes difficult to find out. This is the thing here. This is so that's where so these phase data sets has been used by us in handling this problem. It's 1 hour. Better we can take a one break. I hope the document image definitely. I am telling you, whatever you take in the image is a lot and lot of history. Only you need to see one thing, two things there. That whether are you able to get the literature and the related database, because we finally related literature so that you can see the thing, and related database is also essential. So see, generating your own database is not a practical task. Big institutes can do that. See, we, especially as a candidate, when you have the limited time to do the things, it is, so you see the how many databases are available where you can do the rest. So at least it should be two in number. If no more any databases there, or you are finding difficulty in that database is not public, then definitely you need to revise the database and available literature. These are the key criteria. So here we take a small break, right? We will be back. So we welcome you back. Any questions, please? So this is a week basically for the application. This is the time of winter solstice when new season actually emerges. You move from basically one part to another. So we are moving from basics to the application. Yesterday we celebrated World Meditation Day, and today it is the shortest day in a year with longest duration of night. Any question, any query, any suggestion, whatever it is. So see, thereafter then we move towards the evolution metric. So see, as somebody that asked that what is the base of the research? The base of the research should be the database, availability of the database and the good literature. If it is available, then the things are fine. So in evaluation matrix, so what do you do? Whenever, so once you find out the database, then you will apply the technique, whatever technique algorithm you have basically designed, and then you check out the accuracy. Then you check out the precision, then you check out the recall, and thereafter basically the F1 is. So this way, so these are the things. Mainly actually it is basically the accuracy only. What is this TP? Have you seen it in your research? It is, I hope those people who are TP is basically true positive. This is basically true negative. It means which is false case, you are able to find, which is not the case, you are able to find out correctly, which is correct case, you are able to find out it correctly. See, all, are you with me? Okay. Okay. Thank you. So see, this is the value. So other parameters, see, again, definitely, I think in most of the research, uh, this is fine. Accuracy and precision are fine. But sometimes you see the people, when fine difference is there, then they go to the other metric. In that case, you can use the show the other metric. Otherwise, accuracy is sufficient enough to begin with the URL. So now basically the see the summary. So this is the summary. So problem of occlusion. So what is this? So remember so what is it is due to occlusion blocks facial information unpredictably, making recognition harder in case of lighting or pose. See, this is very a big problem. See, for example, you would have noted down. See, for example, when we are taking the photograph, many times when we are taking the photograph and the lighting condition is not proper, it is very difficult to uh, recognize the face, pose, etc. So the lightning condition becomes very major issue. So what is the say? Can you suggest a solution? For example, when light to avoid this lightning condition, is there any way to identify the person? Yes, there is a way, and that is basically the person who is coordinating with you on the WhatsApp group. He is doing the research in that field, and that is basically the wave radar. There we are able to find out the person, identify the objects without need of light. Anand is doing basic research in the using the wave radar. Even see these cars, etc., driverless car, etc., they are also based upon it. What is the advantage that when you why the wave radar? Because basically 100-meter distance, etc. What is its limitation? What are the limitations? Whenever you see any research, etc., find out the limitations, that what limitations are there in any field, so that we can think about it. We can devise our strategy better to take care of it. So in our case, the techniques are grouped into occlusion robust features, occlusion aware methods, and occlusion recovery approach. Occlusion robust feature is basically focused on features that work even when parts of the face are hidden, using methods like LBP, local binary pattern, scale invariant feature transform, and deep learning. Occlusion aware method. So here, see, you don't bother about an occlusion robust features. They are robust to the occlusion. You don't need to worry. Occlusion aware. Here, what do? You identify or estimate occluded regions to exclude them using classifiers or by focusing only on the visible parts. When it is possible, when it is a minor part, when minor part is occluded, or it is a non-significant part, that even whatever part is available, that can be taken care. Then thereafter is the occluded recovery method. When significant part is occluded and it is necessary, then you need to reconstruct missing that facial part before recognition using models like PCA or advanced deep generative model. So what database we have used? We basically use a data set like the real AR and synthetic. As I told you that we need to provide the synthetic data set because uh, it becomes really difficult to train our method with one data set. So that is the another solution. Then what did we do in our research? In our research, basically we use basically the deep learning performs compare deep learning with the traditional methods where deep learning performs well but needs lots of data. So in traditional remains relevant for efficiency and low data scenario. The proposed solution goes next step model aiming for robust real world recognition without needed extensive training data. What did we do? So that's basically we did. So that's our paper was accepted. So here see the space recognition using threshold string representation under constraint. Whenever you are doing any thesis, so for your every goal, you better we have some paper, then it is validated. So it's a proposed method. So what is basically the thing? Here you see the extraction based where you are divided into two parts. One is basically the holistic based approaches, and holistic based approaches are more sensitive to occlusion. They don't provide good accuracy. Local feature matching approaches, hidden Markov model, NBN and CSMR, and these are using patch based approach. So what is the thing? So what do we do here? Here we use basically gallery images, patch generation. Use basically difference of patches. Then you use clustering. Then basically gallery cluster representation and the probe image which you want to check out that whether it is the correct one. Then you use patch generation, difference of patch. It maps to cluster, and then you probe cluster representation, and then you match both of them. The proposed method is basically the combination of difference of patches, clustering, feature matching algorithm. The proposed method uses pixel level differencing by difference of patches scheme to encode local structural changes. So this makes the representation more sensitive to texture transition, edges, and spatial discontinuity. So local differencing is well known in for capturing structure patterns and suppressing redundant low frequency information. No mean or standard deviation. So this is the thing. So what we are saying here, again, now you go back to our basics. What pattern we use? We use basically the spatial pattern. In a spatial pattern, we use basically the neighborhood. So neighborhood actually we are using the pixel level difference and patches. So pixel level is not sufficient. So because patches, so what we are doing, patches is actually a one patch is basically a set of means a given set of chunk. For example, this is an image, and what we are saying that this is a set of patch P1 and P2. Why we are taking it? Because from the problem itself, it is clear that when we are saying that it is occlusion is a problem. So you can't take the whole image. So better what you do, you take the related patch where the features are well visible. So no mean or standard normalization is applied at the patch level to correct illumination. Only what is important here, only consecutive spatially adjacent patches are considered for difference. What is basically the difference of patches? Here you can see here. There is basically image partitioning is there. You divide the image into capital N non-overlapping patches of size, that is basically P equal to P1, P2 to Pn. Then you vectorize the patches. Basically, whenever you need to do the mathematics, you need to make them a vector. So now you make them a vector, and then you do basically the difference of computation. How you are doing the difference of computation, that has been shown in this example. So this is basically 6, 8, 12. For example, this is the patch, this is the image here. Again, the patch is like basically the mask only. Here again, there is a P2. So finding the difference that you have taken the difference, so that's not a very difficult task. So that you have taken here. What you are saying here basically that you are taking the difference which is you map to cluster and cluster based representation. All difference of patches are converted into cluster centers by applying the k-mean cluster. And what do? You assign S cluster with related difference of patches. You find the local distance between each image and cluster center. You select the cluster center with minimum local distance and assign it to the difference, compute it and find the distance here, then stop process when centroids or newly formed cluster do not change. So as like if you see in the example earlier, then that we had been considering the first day that for example during the segmentation process, that when your this point remains same and centroid do not change, it means you have able to achieve the cluster. What do you mean by gallery clustering representation? You get the cluster labels assigned to difference of patches. You represent a gallery image as a string sequence. Find the local distance between probe image and within cluster center. Select the cluster center with minimum local distance. Get the label. Then you represent a probe image as a string sequence using the label of cluster center. Okay. So this is basically where you use the representation. You need to find out a threshold, that if your threshold, if it is more than threshold, then it is fine. This is basically a use it experimental evaluation using different. So this is basically the database. Sample images are there where many are occluded. These are actually overall data sets. So here actually we have masked them with some noise. This is another synthetic data set, LAV data set again. So we have introduced some patches to made them occlude. Many times when you are not able to get the data set, so what is the choice? Then you use a synthetic occlusion. So what is this we call? This pattern, this is very baboon image patterns along with the illumination variation. You can see the illumination variation here. So this is the basically the result. When you see the result here, see this is the gallery image. Gallery image here, it is shown here. So this is a recovered face, and when you see the probe image, after probe image, three types of scenarios here. Considered when gallery faces are non-occluded and probe faces are occluded. When gallery faces are occluded and probe faces are non-occluded, and when both are occluded. In this scenario, we have this is basically a recognition rate when gallery face edges are non-occluded, probe faces are occluded. So what you can see here, so in sunglasses, if you see the sunglasses and the scarf, you can see the accuracy. With our method, it is very good here. And the scarf, it is also very fine, natural accuracy. Case 2 and 3 when we have taken it. So what you can see here, that in our proposed method, again, see the methods have come better. And then in this proposed method, here the methods are bit better. Results for ORL data set. So here it has been shown here. So again, proposed method it has been shown. One other basically we are using block-based particle swarm optimization. In that you use the images, you basically use a phase detector normalization, you use a block division. Thereafter block division, you extract out the feature and you PSO for feature selection. And then after the training, you classify a model for matching. And so what we do, you extract out the feature, you basically train it, and then your model is classified, and then you test it, and then you recognize the face. So what we are saying here, we are saying simply one thing, that we are using basically PSO for the feature selection. Whatever feature we have already extracted, that will be uh, trained and tested. So here it has been shown here that in you initialize the particle swarm and blocks here and particle random position, evaluate the fitness function, the particle swarm optimization. If fitness P is better than the fitness of best, it is equal to P. Q is the best with the best fitness. So here it has been shown here, that symbol different here. And see here for the ELAP data set, initially we take for the AR data set. There also you can see the, so when this, what is this shown here? This method is basically that much part is occluded. When that much part is occluded, so what we are saying, we are saying that as soon as the ratio of the occlusion has become larger, it has become difficult to identify. But even see our method was comparable in comparison to the other method. So this is for the ALAV data set. So here we have calculated, and here we have calculated for AR data set. And thereafter, we have calculated it. So this is basically the result here. What is basically the summary? This method is basically threshold representation and combined feature extraction and k-means clustering algorithm. So robust, so it was basically degraded in case of the synthetic occlusion. That's why the PSO feature selection is implemented to enhance the performance and impact of feature selection algorithm. So this technique performs well when images have the minimal variations in pose expression and occlusion. So the occlusion disrupt feature consistency, leading to incorrect recognition. So overall, it's provided good accuracy in natural occlusion with grades of synthetic occlusion. Then you basically took up the occlusion detection approaches using graph cut technique for occluded face recognition. So basically graph cut technique. So what did you do? Here basically the input image was there. Here you basically crop the image and thereafter you random rectangular block generation and then you object impose on the face. So then we are saying basically that it is occluded face image you graph constructed and you occlusion segmentation you get the non-occluded region. You compute the Laplacian matrix. I hope now you'll be able to recall the Laplacian matrix that how do we calculate it -4, 1, 1, 1 there, and then you do basically the features matching and then verification and identification. So thereafter, basically, it is a methodology. In methodology, so what we are doing that is basically the shown here that in graph signal, etc. It has been shown to you in graph construction. Face images they are assigned edge weight by Gaussian kernel obtain graph signal maximum cuts and graph Fourier transform. What we are so what is this thing? So when we are saying it in this part, they have evaluated Laplacian matrix that is in context of the graph signal processing. That has been shown basically the graph segmentation. So again, see like the image segmentation. So how we are going to do it? First, to occluded face image represented as undirected weighted graph, and it has been shown here. So then occluded, non-occluded region are obtained by solving this one. Then you define a feature vector, and thereafter you define the neighborhood size, and then you represent the key variable parameter, and then confidence threshold. See, this is how basically you evaluate the Laplacian matrix. So this is basically L equal to D minus W. What is this? D? D is basically the diagonal. What is W? W is basically the weight matrix. So as from this operation, this clearly see that their dimension are of the same size. And what is this UL and X? X is basically the initial vector, initially your input signal vector. And what is UL? UL is basically the this is basically the we say this is the eigenvalue. First we calculate the eigenvalues, and this is the eigenset pair, eigenvector set pair of the N that has been defined. That has been shown here, where the U represent the set of eigenvector. Right. So occlusion segmentation. What we are saying in the occlusion segmentation result, as we are seeing here, this is the occluded images. Here, see, occlusion detection is here either you apply the mask here after graph. So here we are using three segmentation. When you are segmentation, so after detecting occlusion, we are using the non-occluded for the original image where you mask it the this one and then you find out the segmented image. So after the graph segmentation of synthetic occlusion for AR data set, it can be done. So what do you mean by the occlusion segmentation? Occlusion segmentation again, we say it is basically the edge detection, is the region division, the clustering method, it is random walks, it is graph theory. So there we have calculated the accuracy has come basically the 92% here. Time and space complexity of this method for individual components on AR data set, it has been shown there that, for example, when we use the segmentation only, that segment, the accuracy is this one, but when you use the see graph Fourier transform for full image, so this is basically the one. When you the graph wavelet transform full image, that is this one. But when we take only the visible region, see the accuracy has been improved. Generally, it is said that more when we are saying it's so important part here, see, when GFT is basically apply on the visible regions and GWT also on the visible regions, their value 0.88, it has been greater. It has been greater than this one, and here 0.833, it is greater. So what is the thing basically graph wavelet transform? Graph wavelet transforms, what do you do? Again, see, it is based upon the graph signal processing concept. In graph signal processing concept, so it is basically the in graph signal. So the what is the difference between graph signal and the other things? See, here the interrelationship also taken into account when you represent the signal basically using the weighted matrix. After seeing it as a weighted matrix, it becomes equal to the result for the AR data set. For AR data set here, it is shown here that it is recognition rate is there, that is scarf and sunglasses, it has been shown here. Again, we use these data sets frequently, so this is our approach for the GWT. When we represented the signal using basically the graph signal processing, so here you can see when that feature has been used, so our result is basically 99.9 and with the scarf is basically this. And if you see it, this is fairly a good result. That also we are able to compare with the other methods. What is the summary? Summary is basically that the proposed methodology leveraging graph cut based occlusion integral Laplacian matrix for presents. So here see what we see that GWT is able to get basically the better feature localization, multi-scale representation, and improve robustness. But this face recognition suffer when key facial features are occluded. Then occlusion is to obtain the feature. Now in the see this part, see what we are doing basically. There's a feature recovery approach using GFT technique for occluded face reconstruction. So when the occlusion is up to a level that it is not the image cut after the occlusion is not sufficient, then what you do? Then you reconstruct it. Here that we did. So what did the change? So basically the face image data set and face image data set you basically assign as weight by Gaussian kernel. So it is basically the again the to construct the graph. See, for example, we are saying that the interrelationship part is taken into care by that weight matrix. So how do we take that weight matrix? For example, we take an example. For example, three nodes are there. So can we calculate for this matrix? So for example, 1, 2, 3, these values are there. For example, this value is 5. This value is also 5 and this value is 5. So what matters? See, they are their individual values. But what value matter when we make a graph? See, what is the interrelationship between the 1 and 2? This 2 and 3. And their weight is basically, we say it is 4 here. Between 2 and 3, it is 8 here. How will we make a matrix? So what will the matrix between 1, 2 and 3? When we make a 1, 2 and 3, so it will be a diagonal matrix. 1, 2, 3. 1, 2, 3. Between 1 and 1, it is 0. Between 1 and 2, what is the value? Are you able to see? What is the value? Can you tell? It is 4. Between 1 and 3, is there any connection? No, it is not a connection. Between 2 and 1, is there any connection? Yes, it is 4. Between 2 and 2, it is 0. Between 2 and 3, is there any connection? Are you with me? Between 2 and 3, is there any connection? Yes or no? See the diagram. It is not that very good drawing, but at least you are able to identify. Sojan, Snehal, Vivek, it is 8. Nishira here. Nishira is saying 8. Yes, it is basically 8. Absolutely. What about between 3 and 1? It is 0. 3 and 2 is again 8. 3 and 3, it is 0. So what is important here? If you see 040, 408, if you even transpose it, for example, this matrix is W1. So what we can say that W1 equal to W1 transpose. It's a symmetric matrix. So this way, see, what do? We assign the edge weight by Gaussian kernel. So again, what we are saying, this is the edge weight, this 4 and 8. So what we are saying, using the Gaussian kernel, we can do it. Then we assign the node of each image, update the mask, divide the image into occluded, non-clouded region, and then you calculate the Laplacian eigenvector. How do we calculate it? Basically, that equal to L equal to D minus W. So we are easily able to calculate D minus W. Then after we either when we calculate the eigenvectors, it becomes basically the we are able to calculate the Fourier transform, graph Fourier transform. Then you calculate the PSNR and the SSI and value. So it is shown here. The data sets has been shown here, evaluation matrix is here, so here this is here's LMS data here. But remember, see, when you reconstruct it, it is not easy. So your accuracy is basically 30.17 and proposed method, number of training images. It has been shown this. So here see as we have calculated the how much time etc. it has taken to calculate, so that we have been shown here. So again, whenever see you have the chance to present the paper in the journal, take the different type of analysis. Because if, for example, accuracy, yes, it is the main thing, but when you are analyzing your result, more the features you take, more the parameters you will take, better comprehensive it becomes for the another person, testing for the another person. compared to the evaluation performance and the existing method. So that has been shown here. The peak signal to noise ratio. See, sometimes because see all these things will be guided by the base paper, what they have done it using the data set. If they are calculating basically PSNR and SSIM, then we are also able to do. So this basically novel phase reconstruction model that enhances traditional method by integrating graph Fourier transform with graph based argument. This approach handles abnormality structural and intensity based relationships. Our model has three constructs on the graph, etc. that we already discussed. This is the last congruent pair. What we are saying that this basically here occlusion handling and face recognition has been achieved through the occlusion robust, occlusion aware, and occlusion recovery recognition. This is basically recombines TSRM with BPS to enhance feature matching. Thereafter, graph cut based detection with GFT and GWT, and then you basically using the reconstruct the part using IGFT. So when you are reconstructed, see then how do you are calculating? Here you are calculating a strong PSNR and SSII performance. This is the enhancing consistency under serial. This is also this basically the objective. These are have been shown here that explore. So what are the objectives? So that's how PhD people do it. Key contribution result explore different methods based on this one, supporting and limitation of the existing method based on the ORFR, ORFR, improve accuracy using robust feature extraction. So what did they do? They patch based dictionary and graph features to maintain an accuracy, preference, and clue and handle both well. Distinctive feature graph cut segmentation with GFT, GWT feature extraction. What was supporting evidence in table, etc. The different values have been shown. Improved face reconstruction here. IGFT based reconstruction graph Laplacian here in table 5.2 to 5.3 it has been shown. Created synthetic database for research. There also in figure 3.6, 4.4 and 5.2 multiple occlusion type was successfully submitted by the here at different. See, whenever you are doing the research, again, it's important to tell that research is never ever the concluding. You achieve some goal, but many goals are still to be achieved. For example, when we integrate basically modern deep learning, so what we are saying that we basically the GNN basically you graph neural network, and then graph Fourier transform, graph Euler transform using learnable here that suppress occluded region. Vision transformers, that is basically a new concept. Here you use a self-attention to focus on the non-occluded patches for better recognition. Hybrid models, here you combine the lightweight GSP features with the DS network for efficient, robust OFR. Many times you see that GSP is fine, but any new technique is fine, but you can also use it with the deep learning, etc. But need to see the balance that how much complexity it is there and how much accuracy it is there. Then another thing, multimodal biometric. See, not only see it is face and need to identify through image only. You can use voice also, speaker verification when facial occlusion is high. Even these are gait. Basically, your posture. You improve surveillance by using gait and partial face feature. So here it has been all that the biometric problem it is not necessarily to be addressed by the face only. Even you can use these things, gait, voice, and because these signals are also very clearly visible. When you use the temporal fusion, you use the information from previous video frames to improve reconstruction. So this is a real world deployment and optimization. So what we are saying that in basically the for fast safety processing, practical application, mobile authentication, improve face unlock, reliability, mask glasses, border security, reduce fast rejection in high security environment. Because see, their light etc. is not fine. So in these conditions, in all weather conditions, we are even see we are basically working on using the MM radar to identify the facial expressions. And especially in the weather condition, especially in the dark, etc., when you need to know the number of the persons who are sitting behind there. Because see, even it is not safe. I mean, even sometimes it is not convenient to switch on the light in car, etc. There also it has been very. Other parts are means other mediums are useful, which are based on non-light medium. forensic analysis, support reconstruction of partially visible faces. So there you need to actually uh, do the things, take into account the, but only problem there come here is that the database, the available databases becomes actually a key issue. So that variety actually is missing. Then healthcare, see in healthcare you enable reliable identification when masks are mandatory. Again, see we started with that notion that with the mandatory mask we will able to identify the people. These are basically the see the publications by the combined publication with the Manisha. This is our again see this is Manisha you are seeing here. This since he has passed out on the say 27th of November, she defended her PhD thesis. Thank you. So, any question? So now it's a time of question. So this is the application. I think today it's a bit light after taking many long hour sessions. It was a full marathon. Today it's like a half marathon. Overall, it's 2 hour journey. I hope so you would enjoy it. So, so tomorrow, see what I am basically planning to cover that tomorrow I have to take the 2 sessions. So in one session, we will, I hope, see cover basically these medical images, etc. Another medical image is the work which has been doing by the Suman. And in another presentation, see what I'm thinking that this facial expression and my work was actually the facial expression recognition. What I'm thinking that whether can I present these things at basic level? Can it be done? That I will try to do in the morning session. I hope see you would be encouraged to now do the research in this topic, in the topic of image processing. Thank you. Thank you. If you so don't have any, so we concluded. Thank you all. So tomorrow, see in morning. So what I'm planning that can we come up with more basics? Actually, this is a bit application. So can we come up with something basic of any application? In afternoon, we will cover basically the medical image part, which is primarily done by the Suman. He is very well doing in her fifth semester only. Thank you all. Tomorrow at same time, it is 11 a.m. to 1 p.m. and then afternoon 3 to 5. And then on 24, we have in morning, we will conclude it as we have already taken the extra lecture. So there, 11 to 1, we will take up the lecture and thereafter we can take valedictory or we can include the valedictory in between. We can uh, finish it earlier if we finish it early. So at 1:30 we will be definitely get free. 1:30 p.m. on the 24th of December. You can enjoy your Christmas. You can go to enjoy your Christmas at your place.